everyone, today we are talking about the first part of lesson 14.2, which is going to talk about measuring angles in radians versus degrees and converting between the two forms. Now in class we talked a little bit about the idea of the relationship between 2 pi r and the circumference of a circle and its radius. So the reason that we're talking about that is to talk about the overall idea of a radian. And what a radian is it's the central angle of a circle which subtends an arc equal to the length of the radius, and it has the central angle of 1 radian. So it's that special relationship between the radius and the circumference of a circle is where the radian comes from. And in the case of this, when we have this relationship happening, that's where the 1 radian idea comes from. And that's illustrated here. Now, when we're talking about our circle in general, we know there's 360 degrees in the circle, right? Which means if we wanted to think about, again, that activity going around that circle one time, it was 2 pi r, which if we have a unit of 1 for our circle, we would just say is 2 pi. So the next piece then talks about looking at then that conversion. So again, 1 full rotation is 360 degrees or 2 pi radian. And if we convert then, 1 degree is going to be worth pi over 180 radians, because we're looking at that simplification of 2 pi over 360, right? And we're trying to get our degrees to become radians. On the flip side, if we want to find the 1 radian, 2 degrees, that's going to be 180 over pi because of the flipped fraction of that 360 over 2 pi simplified, okay? Now, if we are going to use these then, we are going to convert. So reminder, when you're converting from degrees to radians, you're going to multiply each time by pi over 180. So we're going to simplify the fraction, and our goal is to leave this as exact answers, aka leave the pi in there. Now when in doubt, if you need to simplify, your graphing calculators, you hit math and then frac, will do the simplification for you. So 1/4, aka just pi times 1, so pi over 4 would be our answer there. Okay. Same thing when converting with the negatives, it's that same idea. Multiply by pi over 180, so negative 210 divided by 180. And again, if you want to make sure you're simplifying correctly, graphing calculator is your friend. Negative 7 pi over 6. So it's just essentially remembering to put the pi with your final answer. Don't type it into the calculator though, or you'll get decimal approximations. Now we also want to be able to convert between forms. So for number 5 here, if we're converting from radians to degrees, we want the 180 over pi to be our multiplication factor each time. And the reason that we like this is because our pi's cancel out, and we're left with 180 over 2, which is just 90 degrees. Another example here, we have, again, multiply by that 180 over pi, pi's cancel, and we're left with 360 when we multiply the 2 times 180 over 3, or 120 degrees. Now notice here on this last one, there isn't a pi to cancel out with, so unfortunately, we're going to have to just either leave this as 720 over pi, or the which would be an approximated value here, approximated, if you do the squiggly lines here, of about 229 degrees. In case, because again, normally you want your degrees even approximated, but either one there. So again, usually though, there is a pi associated with the radians to cancel out. Now this next piece here is asking you to determine what quadrant or axis each of these lay in. Now one way to do this, especially when we're talking about radian values, is to convert them back to degrees. So if we have pi over 5, if we convert this to degrees, we end up with 180 divided by 5, which is 36 degrees. And if we think about our picture here, we have these 90-degree quadrants, so 36 degrees would lie in quadrant 1. Now the next one, they're giving us actually a negative value, negative 4 pi over 7, which again, if we convert 180 over pi, we end up with negative still 4 times 180 divided by the 7 gives us negative 102 degrees. So this is going to actually land us in quadrant 3. Now 3 pi over 2, if we cancel the pi's here, we have 3 times 180 divided by 2. That's actually going to give us 207 degrees, which we'll see here is actually part of the axis. So we would say this is the negative portion of our y-axis. And last but not least, 11 pi over 8, if we convert, multiply by pi, or excuse me, 180 over pi, pi's cancel. 11 times 180 divided by 8 is 247.5, which again is going to land us in quadrant 3. Now, the reason that becomes important is eventually in time, you're hopefully going to not have to convert these radians each time. You start seeing that there is a relationship between pi over 2, pi, 3 pi over 2, like we talked about in example C, and eventually back around to 2 pi. So between these and kind of looking at your fractional values on where you fall there. Now, just like we did in the last lesson, we can also draw these radian measures in standard position. And again, I'm challenging you to not have to convert each time. If we're just going 1/4 of a complete clockwise rotation, we're going down here in our picture for clockwise. And if we're only going 1/4 of 2 pi, that's 1 pi over 2. And because we went in the clockwise direction, it would be negative, okay? Well, 2/3 of a complete counterclockwise rotation will require us to take 2/3 of 2 pi. So in this case, that is 4 pi over 3. And 2/3 of a rotation is going to bring us into quadrant 3. And this one's going to be positive due to the counterclockwise rotation. Last but not least, we have 1 3/4 counterclockwise rotation. So now we're looking at 2 pi plus 3/4 of 2 pi. So what that ends up being is a total of 7 halves pi. And again, if fractions are not your thing, reminder, just don't type the pi in the calculator. Just remember to put that in your final answer. But your calculator can help you with the simplification here, especially the fractional portion. We get that 7 pi over 2. Okay, so moving around here, clockwise 1 full time, and then another 3/4 brings us to, again, that negative y-axis would be where we're terminating. Now, just like we had coterminal values with our degrees, where we added or subtracted 360, the same thing can happen with radians, but again, we're using that radian value of 2 pi. So you're adding or subtracting multiples of 2 pi each time. And again, there's an infinite amount of coterminals to radian values, just like degrees. I like to think of degrees and radians like we do inches and centimeters. They're still measuring the same thing, but they're just doing it in different units. Okay? So if we're looking at coterminal values to 3/5, one positive and one negative, well, we would have to take 3/5 and add 2 pi to it, or in this case 2. So we would have 13 pi over 5. But we would also want to be able to take 3/5 and subtract 2 pi away from it. So that would be negative 7 pi over 5. So again, it's a reminder to make sure that even though you don't type it in your calculator, you're aware you need to add the pi to this. Again, if you type the pi in your calculator, you get irrational answers. Same thing with the negative values. Negative 2/3 plus 2. So we would have 4 pi over 3. We also can subtract from 2/3, negative 2/3, the 2 pi, to get that negative coterminal value of negative 8 pi over 3. Okay, so calculator is your friend when it comes to fractions, that math frac button. All right, last but not least, just like it was useful to be between 0 and 360, it is also oftentimes nice to be between 0 and 2 pi, so we are just on the one coordinate axis. So again, sometimes it's handy to have this calculator and just be able to subtract n number of times we need to till we get to a value that is between 0 and 2 pi, aka in this case 1 pi. And then with negative 32/5, we're going to have to add 2 pi multiple times. Okay, so we would add 2 pi to this. Well, this is still negative. And what we're seeing here is it's going to take adding this multiple times until we finally get to 8/5, which is between 0 and 2, aka 8 pi over 5. Okay. All right, so big things for today. We're back here with the making sure we understand that the radian is just another way of measuring, again, kind of like inches and centimeters. We have radians and degrees, and then the same idea with our conversions. Important to have this conversion piece written down as well, converting from 2 degrees from radians and 2 radians from degrees. We will carry on with the rest of 14.2, starting in the next lesson.